Okay, now it will be recorded. Okay. Uh, First of all, I just want to explain this is not our regular main class for 2027 students. 2027 students, we have group number 1 and group number 2, two classes. Okay, in group number 1, that's our main class. Group number 1. Group number 1, we have more number of students in group number 1. It was commence just finish your O level. Okay, now we have covered more than 3 months on in group number 1. It is Thursday 6:30. This is group number 1. Okay, in this group, our main class, we have covered, now we have covered measurement lesson. This is our what is this? Okay, okay, no. In group number 1, we have covered our measurement lesson and the forces lesson. Okay, that's mean our lesson number, we have covered lesson number, second lesson number 2 and lesson number 4. In your class, group number 1, group number 2, and I'll explain later. Group number 2, it is Saturday 4:30. Saturday 4:30, group number 2. We have, now we are doing measurement lesson. Now we are in the end of measure first lesson number only ongoing. Lesson number 1. Okay, ongoing lesson number, sorry, 2. Lesson number 2 mean our first lesson. This is measurement is not our first lesson. Okay, after that, you can see lesson number 1. Lesson number 1 is area and volume. Area and volume, that's a basic math lesson. And lesson number 3 is trigonometry. Lesson number 3, area and volume. Okay, overall we have 25 lessons. If you want, I will send you a syllabus into your group with all lessons. So the lesson number 1 is area and volume. That's a maths lesson. Lesson number 3, trigonometry. That's also basic mathematics lesson. Trigonometry. Okay, now from September month, that means next week, in our group number 1 main class, we start these lessons. Group lesson number 1 and lesson number 3. As a one seminar series, we discuss both lesson number 1 and lesson number 3 as basic mathematics lessons. We start from September. Are you clear? Okay, now okay, now. Okay, I told you in our group number 1 group number 1 menna metenta අපි එද්දි. That means when we complete first 4 lessons, මේ හතරක් කරද්දි for your group also I hope to complete these 4 lessons because group number lesson 1 and 3 we can cover in the weekday class, and weekend Saturday class we can continue these 2 lessons. Okay, after completing group number 1 lesson, group number 1 class 4 lessons, first 4 lessons, your class also I hope to complete first 4 lessons. And today we did the first mock exam number 1 for group number students, group number 1 students, mock exam number 1 for group number 1 students. Then after completing these 2 lessons, you also have the same exam. You also have, I will arrange a time for the same exam for your group as well. Then you and group number 1 in same level, then we can stop this class and you can directly join with this class, group number 1. That's my plan. Any problem? Make up group number 1, group number 2. Well, as soon as possible I will connect with the group number 1, our main class. But you cannot directly join with this. The problem, we have already covered 2 lessons, 2 very important lessons in group number 1. Sadhu, are you clear? Any doubt about our plan, you can ask. The problem, from next week, next month, you have 2 days classes, 2 days. That's only you have the problem. Saturday class going continuous as usual, and additional weekday you have class. I not decide. Normally it's going Thursday, but due to few problems with other students with other class, I will let you know what is the exact weekday for this lesson. Start area and volume. Within today or tomorrow, I will let you know what is the day. Are you okay with this? Then for 1 week you have 2 classes, and you only need to pay for 1 class, no need to both. Your class fee only you need to pay for 1 class, other one is free. Any doubt before go to the lesson? Yeah, I will let you know the day, exact day. Any other problem? Vihanga, are you good? Yes, from next month you have 2 classes per day. Saturday 4:30, and I will let you know what's the date, and normally 6:30 p.m. 4:30 p.m. to 6:30 p.m. In our main class, we doing 2.5 hours, 6:30 p.m. to, normally we starting from 6 p.m. to 8:30. Okay, that's your schedule. I will let you know this date as soon as possible. Okay. Now let's move into our lesson. Are you clear? Sadev, Priyanka, Sandeep, Ayash. Okay. Okay. Go to the lesson. Oh, sorry. Okay. Last day we already discussed parts of micrometer screw gauge and their functions, and how we use the micrometer screw gauge. We discussing in this lesson. I will give you small summary. In this lesson, we mainly discussing measuring instrument, length measuring instrument, mass measuring instrument, time measuring instrument mainly. In now we are doing length measuring instrument. Last 2 weeks we already discussed, completed the vernier caliper. This is our first length measuring instrument, and this is our second length measuring instrument which we use to get to measure very smallest measurements. This is the micrometer screw gauge. This is a micrometer screw gauge. This is the shape of micrometer screw gauge. We already discussed their parts. uh, Wait a second. Okay, this is the micrometer screw gauge. They are the parts of micrometer screw gauge. They are the parts of micrometer screw gauge. I told, now can you send me the parts of this for refresh? Can you send me, what is this? What is this? Quickly. Can you send me main parts of micrometer screw gauge? What's the name of that? This part? Anvil, very good. This one? Anvil, Anivile. Anvil, good. Spindle, spindle, spindle. This one, uh, wait. This is anvil. This is a spindle. This is the linear scale, linear scale, linear scale. This one is the, what is this one? Very good. It's circular scale. Circular, circular, circular. Oh. Circular scale. Circular scale. This one. This one. Sadev. Very good. This is thimble, thimble, thimble. And this one, final part. And this is the frame. Send me this one. This is frame. Frame of the instrument. The U-shaped frame. Yes, this is a ratchet or thimble head. Ratchet. R-A-T-C-H-E-T. Ratchet. Ratchet. Okay, they are the main parts of micrometer screw gauge. I told last week how we get measurement using this micrometer screw gauge. Okay, I will quickly show you how to get a measurement using this micrometer screw gauge. Okay, we have our object. Object is missing. Yes. This is the. We can move this. Oh. Why we cannot move this? Okay, now okay. Okay, this is my object. First of all, I told the object need to place close to the anvil. Okay, this is my measuring object, and the object need to place close to the anvil like this, close to the anvil. And after that, we just need to rotate by thimble. When it is rotating, what happened? The circular scale rotating and the ratchet move into object direction. Ratchet moving to object direction like this. Ratchet moving to object direction. Ratchet moving to object direction. Okay, I told when the spindle come close to the object, we need to stop rotate by thimble. Why? If I rotate continuous, it is possible to over tight. To avoid over tightening, we need smooth rotation. For smooth rotation, we have to rotate by this thimble head or ratchet. Okay, now I am going to rotate by thimble head. Okay, when it is tight into a required level, you can see it's coming specific tick sound. Specific tick sound. Hear this? Can you hear sound? Yeah, when it is tight into maximum, it's coming tick sound on the instrument. Then we can decide the object is tightened between anvil and spindle in required level. Required level, it is tightened. Okay, now this is the instrument and parts and how we use this micrometer screw gauge for get any length of or any diameter of any object. Normally this micrometer screw gauge we use, I told, it's used for to get small measurements. Large measurements like 10 to 12 millimeters we cannot so 10 to 12 millimeters, okay, 10 to 12 centimeters we cannot get. Okay, what is it? Do you remember what's the maximum measurements of the micrometer screw gauge? Maximum kiyada ganna puluwan? Very good. In linear scale, I told the maximum value is 24 5 millimeter, then I told 2.5 centimeter is the maximum measurements that we can get from this micrometer screw gauge. Very good. Okay, I told final point we discussed. Final point last day. Final point. I told the least count of any micrometer screw gauge. The least count of any micrometer screw gauge. The least count of any micrometer screw gauge we can calculate by small equation. The screw gap divided by the circular scale. Screw gap divided by the circular scale number of parts on circular scale, number of parts on the circular scale. Okay, this type normal micrometer screw gauge. Last week I told, how about this screw gap or pitch? I told there is another name for screw gap. It is pitch. Pitch කියලාත් කියනවා. Pitch. What is the screw gap for normal micrometer screw gauge? It is what? Sadev? When we consider about normal micrometer screw gauge, standard one, how about the screw gap or pitch? Others, Sadev? Very good, Sadev. And Bianca? It is 0.5. 0.5. Practically, I explained last week when circular scale rotate one full revolution along linear scale, circular scale moving distance is the screw gap. It can make a one full revolution එකක් rotate වෙද්දී මේ linear scale එක දිගේ මේක move වෙන amount එක කොච්චර move වෙනවද කොච්චර distance එකක් යනවද කියන එක. දැන් I told last day, if you can watch the last week recording, when it is rotate full one revolution එක රවුමක් විතරක් කරකෙද්දී along linear scale, you know, if I rotate one revolution into upward direction, it is going to this side. If I rotate opposite direction, it is releasing, no, this side. The amount, whatever direction, no problem. While rotate one revolution of circular scale along linear scale moving circular scale moving distance, that we called as the screw gap. Understand? Screw gap. Then number of circular scale parts. This instrument, how many number of circular scale parts? 50. I told 50. Then you can get this type. 0.01 is the least count of this type. 0.01 millimeter is the least count of this type micrometer screw gauge. 0.01 millimeter is the least count of standard common type of micrometer screw gauge. It is not always same, but standard in your exam given standard micrometer screw gauge. Normally your questions coming based on standard micrometer screw gauge. In our syllabus only given that one, but you should know these equations. You can substitute this equation for any type of micrometer screw gauge. You just need to measure its screw gap and divide by number of circular scale parts. Then you can get the least count of any measuring instrument. Okay, that up to now we already discussed last day. Okay, today I'm going to explain. Go to the tute. I think you all have tutes. If you don't have, please ask me the PDF. Then within a few days, you can get the printed tutes. Okay, functions we discussed. Circular scale also we discussed. Okay, the least count of the micrometer screw gauge. How we get this? Screw gap divided by the number of circular scale parts. Screw gap divided by number of circular scale parts. This is a point we need to start today, like, right? This is the point, right? Taking measurement using micrometer screw gauge, measurement reading part. We stop in least count, right? Yes. Yes. Then we'll see how to read a measurement after taking any measurement, whatever measurement using micrometer screw gauge. We're going to understand how we read this. Without reading, we cannot get the measurement. Then I'm going to, after taking measurements, how we read this measurement using this linear scale and circular scale, how we read this. Okay, I will explain this. This is very simple thing. I will explain in the whiteboard. Then after go to the tube, I will explain in the simulation. Sorry, Ravindu. I will send. I forgot to send. Okay. I told, think we have whatever instruments. After taking measurement, the linear scale and circular scale was like this. Linear scale and circular scale was their positions like this. Think this is the linear scale. This is a linear scale. This is a circular scale, like a cylinder. Okay, then I told the linear scale is calibrated in upper side. Udding calibrate karla tiyenne like this. 0, 1, 2, 3, 4, 5, 6, like this. One by one. Each 1 millimeter has divided into 2 parts by below calibration. 0.5, 1.5, 2.5, 3.5, 4.5, 5.5, like this. Okay, in our reading, first of all, our first step is calculate the please understand very well. This is very important for our future parts. This is a point you need to get maximum understand. Okay, calculate the linear scale measurement. Calculate the linear scale measurement. This is our first part. First step, measurement. Okay, in this given figure, what is the linear scale measurement? Always remember, as linear scale measurement, we just need to get the final value that we can see in the linear scale. Okay, how you can get this? 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6. Then the linear scale measurement is 6. I can make it finally paying a value as linear scale measurements. Sandeep, understand? As linear scale measurements, we just need to get the final measurement that we can observe in the linear scale. Okay, then after that, our second step, calculate the coincide parts. Okay, the circular scale like this. Our second step, calculate the coincide parts. This one we called as there is a middle axis here. In linear axis, there is a straight line that we called as a linear axis middle line. Okay, linear scale middle axis. Linear scale. Make it up again. Linear scale middle axis. Mid axis. You can axis line. It's just a straight line. In our second step of the measurement reading, we just need to get the coincide part parts with linear scale mid axis, coincide number of parts. Okay, in this given one, what is the value of coincide number? Coincide number always we get in the circular scale. See, you can remember always this circular scale value is increasing into upward direction. You can understand this value is 35, then it is 40, then what is this one? The coincide value is, send me, it is 36. Good. Coincide value with linear scale middle axis. Clear? Linear scale mid axis coincide with then it is 36, not millimeter, 36, just 36. Okay, then our third step, this coincide number of parts, just multiply by the least count of the instrument. Okay, it is very simple. Now you already know the least count of this type instrument 0.01, 36 multiplied by 0.01 millimeter. Now you can understand the value is 0.36 millimeter. 0.36 millimeter. Now you can get the final measurement. Final measurement, very simple. Both final measurements. Final reading should be 6 plus linear scale measurements and circular scale final measurement 6 millimeter plus 0.36 millimeter. In circular scale final measurement after multiplied into least count. Then 6.36 millimeter is the final measurement of this given linear and circular scale. Clear? Okay, any doubt? Now, if you understood the steps, that enough, then after that we can go to the simulation and practice any type of questions. Any type of questions we can practice. I got the steps, Sadev? Steps tick okay? First step, calculate the linear scale value. Second one, get the coincide number of parts in circular scale with the mid axis. Fourth step, this circular coincide parts multiplied by the instrument least count. Then this circular scale multiplied value and linear scale value add together. Add karana thiye. Clear? Okay, let's practice few questions. I got steps. Steps only I need. Steps understand now, okay. Then we can do any type of question. Send me. Any doubt? No. Good. Okay, then. Okay, these steps I have given in the tube. Place the object read between anvil and spindle and get the reading on the linear scale. Get the reading on linear scale. That's our first step. Then the number of divisions on the scale, circular scale that parallel to the linear scale, multiply it by least count of the instrument and its value add to the value in linear scale reading. Okay, this is the correct reading value on linear scale plus number of it should be coincide part. It is given parallel. It should be coincide part. Coincide. Please correct this. Coincide divisions on the circular scale multiplied by the smallest measurement mean least count. Smallest measurement mean least count. Okay. Now you have practice question. Can you get this? Please get this value and send. I need the answer from all. Follow these steps, no problem. Follow above given questions, steps. Good. Others? We have correct. Now, can you send me one step by steps? Step by step, Hadam. Come the step by step question. Okay, what is the least count value? What is the least count measurement? Least count okay, final observable value. You can see this line is 20. This line is 20. This line is 20.5. This is 20.5. This one 21. 21.5. 22. 22 millimeter is the 22 millimeter tama 22 millimeter on in the linear scale. Now what next? Get the coincide number of parts. How about the coincide part? Sandeep, what is the coincide part? What's the coincide part? Sorry. What's the coincide part? Quickly. Sadev. What's the coincide part? With the circular scale middle axis. Ashfal. Simple. Very good. It is 33. No? Because this one 30, I told always the value increase into upward direction. 31, 32, 33 is the coincide value. Then this one 33 millimeter, not 33 millimeter. 33 multiplied by the least count. The least count is 0.01 millimeter. Then add these two value. Add these two value. This answer is 0.33 millimeter. Then you can get 22 plus 0.33, 22.33 millimeter. Simple, no? 22.33 millimeter. 22.33 millimeter. Understood? Very easy. Okay, if you got, can you get quickly this one? Is it clear? Clear, no? Yeah, clear. This is the 10, 10. This is 5. Sandeep, quickly send. Very good, Vihanger. Others? Take time and think what are the steps. Go step by step now. Okay. First, you need to practice practice with step by steps. Then after that, without a step, you can read. After practicing this, practice करने का step by step यार. Ravindu, can you read that one? Step by steps. Okay. Send me all. What is the least count value? Least count value है What's the least count value? Yes, Sandeep, correct. Sandeep, okay. If you can send me the full answer. Okay, the linear scale value 10, 11, 12, 13, 14. You can see the final value is 15. 15 millimeter is the final value in the linear scale. After that, plus the coincide part, you can see 30. 30 multiplied by the 0.01 millimeter brackets. Then you can see 15 millimeter plus 0.30 millimeter. Then finally you can get the answer is 15.3 millimeter. 15.3 millimeter. Got 15.3 millimeter. Ramindu, I got? Good. Okay, next one. Same method. Same method. Now, very small difference. Get the full answer and send me. I will give you 1.5 minutes. No need 1.5. I can give 1 minute. Very good, Sandeep. No, Sandeep. Vihanga correct. Sorry. Sandeep, no. It is not the 5.42. Your linear scale value wrong. Circular scale value okay. Sadev, can you send me? One bar. Can you see 6? No. Ravindu, you can't observe 6 here. 6 pen and try again. Yeah, if it is මේ මෙතන line එක තියෙනවා නම් you correct. මෙතනින් යන්තම් පේනවා නම් line එක you correct. But no visible, no clearly visible line. Clearly not visible. Therefore, Sadev, what do you think? No, Sandeep. Wrong. Sadev? No, same method. What is the first step? Get the linear scale value. What is the linear scale value on this one? Linear scale value, I told you need to get the final value of the linear scale you can observe. අපිට පේන අන්තිම value එක. Then this one 5. Sandeep, there is another value here. Another line here. What is this value? 5.5. Because 0, 0.51, 1.52, 2.53, 3.54, 4.55, 5.5 there. Then 5.5 millimeter is there. 5.5 millimeter is the least count value. Then how about the coincide part? Coincide part 40, 41, 42. 42 always increasing into upward. 42. 42 is the coincide. 42 multiplied by the 0.01 millimeter. 0.01 millimeter. Then its value is 0.42. Now the measurement is 5.5 millimeter plus 0.42 millimeter. 0.42 millimeter. How you get this? By adding. What's the value? 5.92 millimeters. Ravind, good? And Sadev, good? Very good. Okay, I will move into final one of the tute. For that one, I need your answers. And consider this value is slightly observable. මේක යන්තම් පේනවා කියලා හිතන්න. The below value. Can you send quickly? Good. There is a line here. Good son, Vishankar. Others? Good, Ravindu. Very good. Sandeep. Sadev. Afsal. No, Sandeep. Good, Sandeep. Sandeep, there is a small mistake. Okay, let's see how we get this. First of all, what's the step? Step number one, get the linear scale measurement. The linear scale measurement 5, 5.5, 6, 6.5, 7, 7.5. Then 7.5 is the linear scale measurement. After that, add 20, 21, 22, 23, 24. 24 millimeter is the coincide part. 24 multiplied by the 0.01 millimeter. Okay, 7.5 millimeter plus 7.5 millimeter plus 0.24 millimeter. Then you can get the value 7.74 millimeter. 7.74 millimeter. Sandeep, where you did the mistake? Calculation error. If you can't add this value, you can use calculator, no problem. Your phone calculator use until you take a scientific calculator. Better to get a scientific calculator app. Then you can practice in your phone and you can take a scientific calculator later. Scientific calculator you can access in your exam. For not only SFT, SFT and ET both you can use scientific calculator, but for ICT you can't use. ICT will take it back. For SFT and ET you can use scientific calculator. Entire A-level streams, only 4 subjects allowed calculators. The first one, science for technology, our one, and the second one, engineering technology. Third one, our other subject, biosystem technology. Final one, A-level commerce accounting. Other any subject, calculators not allowed yet. Sometimes business and econ also it will open within few years, but now up to now only 4 subjects in A-level exam allowed calculators. Scientific calculator you can use in your exam. If anyone try to buy a scientific calculator, please let me know. I will send you what are the recommended, what are the possible calculators, good calculators you can use in exam. Okay. Okay, now I'm going to read actual value, actual diameter of this object. Actual diameter of this object. Okay, first of all, I want to rotate the thimble until the spindle coming close to the object. Then after that, when it is close, I'm rotating by ratchet until it freely rotate. Now it is rotating freely, no any tightening. Then the object tightening to required tightness. Then you can get the reading here. You can get the reading. Okay. What is the diameter of this? Can you read this? Yeah. Now no need this step. Try to get as looking බලපු ගමන් ගන්න පුළුවන් කියලා බලන්න without any steps. Yes, Vihanga can. Vihanga good. Good, Ravindu. Sandeep. Good, Sadev. Sandeep. And Ahmed. Mohammed. Is it 27, Ahmed? Coincide part is 25 or 27? Okay. Now correct. Now correct. No. Yeah. Not correct. It is 27 or 25 coincide. Coincide 25, right? Coincide 25. Then how we get this value? First linear scale value. The linear scale final value to the final value of the linear scale, it is 2 millimeter. 2 millimeter. Then plus the coincide value is 25. 25 multiplied by 0.01 millimeter. Then 2 plus 2 millimeter plus 0.25 millimeter. The value is 2.25 millimeter. Right? Ahmed, Sandeep, I good? Okay, I will give you random measurements. You can try. Okay, quickly. As now, try to improve your speed. Now you can understand this method. Now try to improve your speed. Okay, this one. Quickly get the value. Within short time, try to calculate the value. Yes, yes, Vishankar. Normally, in our exam, normally up to now, every past papers came based on the least count, the standard micrometer screw gauge. But sometimes they can change this. If it is changing, they mention this is the least count of this instrument. Okay, එහෙම වෙනස් වෙනවා නම් එයාලා දෙන්න ඕන. If it is without giving least count, just giving this type diagram, then it is a standard one. එතකොට ඒක standard එකක්. The standard one, the least count is 0.01. But if there are any changing, they will give information what is the screw gap of this one and how many circular scale parts. Then you can calculate the least count and that we can use for the multiplication. Only multiplication. Okay, if without giving information, if they only given diagram, it is standard one. That means 0.01. වෙනස් ඒවා මෙච්චර කල් නැහැ විත් නැහැ. But it is possible to give, but you should know 2 point wait. Yes, Ravidu correct. Sandeep, no. Try again. First, try with steps, step by step. Yeah. How about the linear scale value, coincide parts, and Ahmed also. Ahmed correct, but I don't know why 2 decimal points are changing. Ahmed, your coincide value is wrong. That's why your answer not correct. Others are correct. Other steps correct, everything correct, but the coincide parts wrong. Understand how we get the coincide part. First of all, get the linear scale value 0, 1, 2, 2.5. Oh, that's all are correct. 2.5 millimeter. Then plus the coincide value get clearly get the coincide value. Now correct, Sandu. Get the coincide value clearly. 30, 31. Always increase to upward. 31, 32, 33, 34. Then me if it is 35 less than 1, subtract 1, it is 34. Then 34 multiplied by Ashfal, you have got 32. That's a euro. It is 34, not 32. The coincide value with the middle axis you need to consider. The coincide value with linear axle middle axis. See this one, this value. This one. Then 34. 0.01 millimeter. Then brackets 2.5 millimeter plus 0.34 millimeter. It is 2.84 millimeter. 2.84 millimeter. Okay, final practice question. Get all correctly. I'll give you random measurement. This one. So they good. Vihanga good. Ahmad good. Trying to correct. Very good. Very good, Sandeep. All are correct. Very, very good. Okay, that's the. Okay, if you want, you can get this simulation into your laptop and you can practice more questions. If you want, I will give you this link. Okay, you can work as actual instrument. You can changing. You can practice. You can practice if you want. Okay, normally this type diagrams given, this type not instruments given in exam. In exam questions given this type diagrams. You have ready for this type diagrams. Then the same principle. A link I will send you. I will send you the link. But in exam, they given this type diagrams with these scales. You should know how to get these values by step. Okay, now we move into our final part of the measure micrometer screw gauge. Within next week, we can complete the measurement lesson. Next week, we can complete the measurement lesson. After that, we have a measurement lesson tutorial discussion. That's a tutorial paper based on measurement lesson. Every questions I will give you the to complete this question paper. Then we can discuss that. It's not a test. It's not an exam. After that, you will have exam from both lessons as a one exam for both lessons. Because this lesson is a very small lesson, I'm not going to give you unit exam for this one. I hope to do it after same as group number 1 students after completing this group lesson number 2. Lesson number 2 mean our first lesson, and our second lesson number 4, fourth lesson. After that, I will give you a mock exam number 1. I think for mock exam number 1 for 2027 group number 1 morning exam, it was 30 MCQ. There are 3 students got all correct, 30 marks, and 2 students have 29, and a lot of students 28, and only 2 to 3 students less than 20. All are between 20 to 30. Okay, therefore you also have to practice like this. These lessons actually very simple. If you practice very well, they don't need to buy hard these physics questions, physics lessons don't need to buy hard, only understand this concept and remember with practice. Practicing is very important. As you already know, I told you at least now you have to work 2 hours for, no, at least 3 hours, 1 hour per one subject. In this your level, at least 3 hours you have to work on work for day at least. Okay, if you can more, it's better. At least you have to work 1 hour for one subject to continue to keep your consistency. This consistency is very, very important, and keep always attention with lessons. Otherwise, if you go to another, normally our brain is paper structure. Paper structure mean we have A-level paper structure. Okay, that I will explain. First day I already discussed. If you want, you can go to the recording and check this. First day I already discussed. Then I think batch number 1, your group number 1 class, first day everything I explained, how your paper is coming, what are the practicals you have, what are the lessons in future parts, everything we discussed. If you want, I will give you this recording as well. But if you have time after complete this lesson, I will get 10 minutes and I will explain. Not worry. Okay, we have more time. We are in the first lesson. Okay, this is the final part of the micrometer screw gauge. As we discussed, do you remember? We discussed what is the meaning of commonly what we need, what do you mean by the zero error, and what is the meaning of the zero error of the vernier caliper. Then finally, again, we're going to discuss the zero error of micrometer screw gauge. The zero error of micrometer screw gauge. Okay. Do you remember what's the zero error of any measuring instrument? Any measuring instrument, what's the zero error? The zero error mean what? How we can define? Onama instrument, what's the meaning of the zero error? Any measuring instrument? Without taking measurement? Yes. Without taking measurement or before take any measurement, if this instrument showing some value, showing some reading, that we called as a zero error of any measuring instrument. ඒ කියන්නේ measurement එකක් ගන්න කලින් ඒකේ measurement එකක් පෙන්වනවා. Like before we take any measurement, like if you go to any supermarket or anywhere, any shop, think you try to buy 1 kilogram of sugar or rice or whatever goods. But before you measure it, if this scale already showing some value, display some value, then can you get accurate value from this scale? No. That we called as a zero error. Zero error, the name also given the meaning, the zero error. The zero error means without showing zero, showing another value before we take any measurement. Okay. Now we already discussed the zero error of vernier caliper, right? What's the meaning of the zero error of vernier caliper? Do you remember? In vernier caliper, if you can remember, I told when we this internal and external jaws coincide each others, that mean touch each other. Touch with the, yeah, like this. When the external jaws touching each other without any object, if circular scale, sorry, linear scale, sorry, it is not linear, this one main scale, no? Main scale 0 and circular scale, not circular. That we called as main scale, that we called as vernier scale, sorry. vernier scale. Main scale 0 and vernier scale 0 coincide each other when it is touching together, that we call don't have any error. Like this, that we called as this instrument has 0 error. Then again we discuss the vernier caliper 0 error, mainly two types. What are the types of 0 error in vernier caliper? Do you remember? Do you remember what are the types of 0 errors of vernier caliper? Give me a second. Okay, sorry. Yes. In okay, before understand the vernier mic sorry before understand the micrometer screw gauge vernier uh, micrometer screw gauge 0 error, if you can refresh the 0 error of vernier caliper, you can actually very easy, because it is same as micrometer. When without any object without any object, if we uh, touch together this external jaws of vernier caliper, if it is the linear scale value, sorry, main scale 0, main scale 0 coincide with vernier scale 0 like this. I told this type instrument don't have any 0 error. They are accurate instruments. They are accurate. Okay, then I told the 0 error of vernier caliper. That's not the micrometer screw gauge. 0 error of 0 error of vernier caliper. zero error of vernier caliper, we can divide into three types: the positive zero error and negative zero error. That's in vernier caliper. Okay, positive zero error and negative zero error. Positive zero error and negative zero error. Positive zero error and negative zero error. Then what is the reason? Do you remember what's the reason for positive zero error? I positive zero error activate. What's the reason? Due to the vernier scale zero, shift right side. Vernier scale zero, shift right side like this. 1, 2, 3, 4, 5. Vernier scale zero, shift right side than main scale zero due to corrosion mainly. Corrosion is the main reason. Corrosion or something apply between jaws. Jaws වල මොනවා හරි apply වුණාම තමයි that's a reason for positive zero error. Positive zero error that we could called as a positive zero error. Do you remember how we calculate the positive zero error? The positive zero error we can calculate how? We can get the value of positive zero error. We can get the value. We can get the value of positive zero error coincide parts multiplied by the least count. That's I explained in last lesson. Okay, vernier caliper lesson. Okay, coincide part just multiply by the least count. Just coincide part. This one don't have any one coincide, but in your normal one it is coinciding. One value coincide like this. One value coincide like this, then coincide part 4 multiplied by 0.1 millimeter. This is the positive zero error. Now refresh. Okay, refresh. Then it is easy for the micrometer screw gauge. In negative zero error, what is the reason? The negative zero error, wearing off. Wearing off can be ගෙවීම. Some smooth layers removing from the instrument between jaws. Therefore, what happened? 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It is 10. The vernier scale zero shift left side than the main scale zero. This is the accurate one. They are the accurate. No any error. Accurate. But this one positive zero error. This is negative zero error. Understand the difference. Understand the difference. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like this. Then how we get the negative zero error? This is the most important. Negative zero error we cannot get just coincide parts multiplied by least count. For that, we need to get the total number of vernier scale parts. Do you remember? Total vernier parts. Total vernier parts, I will only write the values. Total vernier parts 10 minus now 1, 2, 3, 4, 5, 6, 7 is the coincide one. Multiply by least count. Multiply by least count. That's from vernier caliper lesson. Okay, then I told 0.3 millimeter is there because 10 minus 7, it is 0.3 millimeter is the negative zero error of this given instrument. Okay, that's how in a vernier caliper, there are two main types of zero errors, positive zero error and negative zero errors. Now we're going to discuss about what is the zero error of micrometer screw gauge. If you anything forgot in vernier caliper, please go through again every recordings I have uploaded into the website. This recording also I will upload into recording upload into website. You can go through. I will not going to delete this any recording. I hope to after you after you pay your class fees, I will hope to give each month recordings until exam. You are completing your exam. But you have to don't wait until the last moment. Please complete everything within given time. Okay, in the same week. Okay, don't keep anything for next weeks. Okay, for your preference only, I can give you a continuous recordings access. But don't pile up works and day-to-day works complete within the same week. Otherwise, this A level will be very difficult if you collect works and without completing. Okay, because day by day the amount bulk, the quantity is increasing. Therefore, every day, every week's works, if you can complete within the same week, for 1 week you have very small amount of works. පොඩි වැඩ ප්‍රමාණයයි එක සතියකට තියෙන. But if you collect and without doing, then for 1 week, in finally you have 1 week you have 2 to 3 months work with you have to cover within 1 week. Okay, it is very difficult. In until last, if you wait until last time, therefore don't keep like complete everything within the same time, within the same week. Okay, I hope you have full idea of zero error of the vernier caliper. But now, what is the meaning of the zero error of micrometer screw gauge? Same thing, but there is only difference, small difference. Okay. Okay, this is the zero error of micrometer screw gauge. Okay, first of all, I will show you how we check the zero error of micrometer screw gauge. How we check the zero error of micrometer screw gauge. Okay, the zero error we can check same as vernier caliper. The zero error of micrometer screw gauge. Okay, this part very important, understand very well. Everyone focus your maximum. Oh, give me a second. Give me a second. Okay, I told you First of all, I'm going to check the zero error of micrometer screw gauge. If there are any zero error available or not. Okay, see, first of all, I need to remove all objects between anvil and spindle. Objects anchor. Then, after that, rotate the thimble without any object between anvil and spindle. Understand? Without any object between anvil and spindle, same as vernier caliper. Without any object between anvil and spindle, going to tight the anvil and spindle. Going to tight the anvil and spindle. See, tight the anvil and spindle. Tight the anvil and spindle. When it is coming close, I need to rotate by ratchet. Then you can see this sound is coming with free rotation. Then it is tight into maximum level. When it is tight into maximum level without any object between anvil and spindle, understand? Without any object between anvil and spindle, when it is maximum tight means tight into required level, micrometer screw gauge, circular scale 0 properly coincide with the linear scale middle axis as given here. It is accurate instrument, don't have any zero error. Are you good? If it is coincide as given here like this, 0 and linear scale middle axis, this type instrument we call instrument without any zero error, accurate instrument. Understood? Instrument without any zero error, accurate instrument. Good. Now very simple thing, don't get very complex. It is very simple thing. Without any object, we tighten into required level. 0, circular scale 0 and vernier scale 0 come as one line, coincide. Linear scale mid axis and circular scale 0 coming as a coincide line, that we called as a accurate instrument without any zero error. Send me all. Are you good? This type instrument don't have zero වලට එනවනම් this type instrument don't have any zero error. Good? Sadev, this type instrument don't have any zero error. They are accurate instrument. Sandeep, are you good? Good. Then what? This type instrument don't have zero error. Then what is the zero error? If it is not coincide, if it is when we tight into without any object, when we tight this anvil and spindle by ratchet, finally we tight by ratchet. This circular scale 0 not perfect coincide with the linear scale 0, that we called as a least count, that we called as a zero error of the micrometer screw gauge, like this. Okay, I will show you in the whiteboard. Okay, keep in mind, if you don't know this vernier caliper, please go through the recordings and complete. Okay. Now, in micrometer screw gauge, when anvil and spindle touch together without any object, anvil and spindle touch together. This is linear scale. Linear scale. Okay, if it is given like this, 0 perfectly coincide with the linear scale middle axis. This type instrument that we called as accurate instrument, accurate instruments, accurate instrument, no any errors, no errors, no any error, no error, zero error, no any zero error. Zero error. They are accurate. But the zero error of micrometer screw gauge, the zero error, zero error of micrometer screw gauge, mainly two types, as we discussed. It is positive zero error and negative zero error. Positive zero error and positive zero error and negative zero error. Same as vernier caliper. Positive zero error and negative zero error. Now we're going to discuss what is the positive zero error of micrometer screw gauge. The positive zero error of micrometer screw gauge, it is like this. It is like this. Okay, I'll show you this one and go to the whiteboard again. The positive zero error may try to get, this is the final part of the micrometer screw gauge. This 10 minutes very important. Okay. Try to focus very well. Okay, now okay. Now see this. Okay, now this is the instrument. This is the instrument. Okay, now I'm going to, without any object between anvil and spindle, I'm going to tight again into required level by spindle. It is required, it is tightened into required level. Now what happened? This is a positive zero error. This is a positive zero error. Now it is maximum tight. See what happened? What happened? This is a positive zero error. The zero not coincide with the linear scale middle axis. That's a problem. The circular scale zero not coincide. And in positive zero error, can you understand before come to the linear scale middle axis? Make a carakila mehema enna kalin before come to the linear scale middle axis. Think if it is accurate, this is the linear scale middle axis. This zero need to come here. But before come to the before zero come to the linear scale middle axis, it is tightening. That is the positive zero error. That is a positive zero error. Positive zero error. Make a culling natara wenna kiyala, you have to understand it is stopping before come to the zero. Then what are the possible reasons? What do you think? What are the possible reasons for positive zero error? What do you think? The main reason, something apply between the surface. Something apply you actually corrosion. Again, malakata bedunam, corrosion between this anvil and spindle. That's the main reason. When it is corroid, you know, smooth surface is formed between anvil and spindle. Therefore, when we tight into required level, before zero come to the middle axis, it is stopping. ඒ කියන්නේ තව චුට්ටක් මෙහෙම කැරකෙන්න තිබිලා මේක නතර වෙනවා. Understood? Got? it is stopping before zero come to the linear scale middle axis. That we called as a positive. Positive. The reason same as vernier caliper. The reason is corrosion. Are you good, Sandeep? Sadev and Ravindu? I got the positive zero error. Good. That's mean okay, it is given here. When it is rotated by holding from the thimble head so that the spindle just touch the anvil, just spindle touch the anvil, the zero of the circular scale should be coincide with the main scale middle axis as shown below, like this. If it is coincide, we consider there are no zero error, no zero error. No zero error, they are accurate instrument if it is coincide. But in some screw gauges, due to some reasons such as corrosion or waste of spindle and anvil, when the thimble head is rotate, so the spindle just touch the anvil, the zero of the circular scale in a position as indicated below. Because of the error will be occurs. Then like this, it can be changed. Now I have given the zero error of micrometer screw gauge. There are two main types, positive zero error or negative zero error. This is the positive zero error. The positive zero error, now you already know, positive zero error before come to the circular scale zero. Circular scale before come to the zero, it is stopping. See, the zero is there. Before come to the zero. Then how we get this zero error value, positive zero error value? How we get this positive zero error value? It's easy. You can get the positive zero error value. Remember, first of error value, not the measurement, error value. Error value means it is 0, 1, 2, 3, 4 coincide parts multiplied by coincide number multiplied by the least count. Very simple. Coincide number multiplied by the least count. In this one, coincide number is 4 multiplied by the 0.01 is the least count. The positive zero error 0.04 millimeter is this is positive zero error. 0.04 millimeter is the negative zero error. Write down in the tute. This is the positive zero error. How we get this coincide part? Just multiply by the least count, same as measurement reading. Note down. That is coincide number of parts multiplied by least count. 4 into 0.01 millimeter, the value is 0.04 millimeter. Okay, final point of positive zero error. Think positive zero, if any instrument has positive zero error. Okay, understand. This instrument has positive zero error. What's the value? The positive zero error value 0.4 millimeter. Positive zero error value is there. Now, if I got any instrument, if I got like this measurement, if I got like measurement using micrometer screw gauge with this error එක තියෙන instrument එකකින්, if I got this value, then can you send me the accurate measurement? What is the actual reading? First get the reading is given in the measurement. Then I need accurate actual reading. Accurate actual reading. The zero error is 0.4 millimeter positive zero error 0.4 millimeter. Okay, send me quickly. First read the measurement, then correct the measurement. It has positive zero error. Keep in mind. Okay, what's the value? Yeah, reading is, yeah, everyone now read. You can get the reading. No, Ravindu? You all can get the reading, no? Reading is, we already practiced the reading in linear scale. It is 3.5 millimeter plus 22, 0.22 millimeter plus 3.72 millimeter. 3.72 millimeter. Yes. 3.72 millimeter. 3.72 millimeter is the reading. 3.72 millimeter is the reading. The actual reading, there is a positive zero error 0.4 millimeter. Then how we get the actual reading? It is a positive zero error. Very good, Sadev, correct. The positive zero error, to get the accurate actual reading, we need to subtract this positive zero error from the reading. Subtract, then 0. No, it is 3.72. 3.72. 3.72 minus subtract 0.4 millimeter. It is 3.68 millimeter. 3.68 millimeter is the accurate reading. Get the accurate reading if any instrument has positive zero error. If any instrument has positive zero error, remember to get the accurate reading. Note down here with star mark. If any instrument has positive zero error, if any instrument has positive zero error, the error value should be subtracted from the instrument given reading. Instrument given reading. Instrument given reading. Given reading. Instrument given reading. If any instrument has positive zero error, the error value should be subtracted from the instrument given reading to get the accurate measurement. Okay, got it? Positive zero error done. Okay, now final point of the lesson, the negative zero error. The negative zero error. In the negative zero error, what happened? Understand the final point of the lesson. In negative zero error, it just like this. When we type maximum, see, okay, I told you, sorry. Okay, I told you in negative zero error, when we type maximum this ratchet, by ratchet anvil and spindle without any object type maximum, the zero of the vernier circular scale zero pass the linear scale middle axis, passing and additionally rotate. You can see if it is correct, it should stop here, but it is now additionally rotate. Additionally rotate. It's rotate additional. No? Then how we get the negative zero error? The negative zero error you can't get by directly coincide part multiplying with least count. You have to get a special method. Remember, I will show you in the tute. This is the negative zero error. This is a negative zero error. Then the negative zero error, we can get the total, remember the equation, total circular parts, now total circular scale parts minus coincide parts multiplied by the least count. This subtraction value same as vernier caliper. Do you remember, say vernier caliper negative zero error? How we get? Total vernier scale part minus coincide part. This one, total circular scale parts minus coincide part, same as vernier caliper. Multiply by least count. Then the negative zero error, the coincide, so total circular scale part, it is 50, recommended standard one, it is 50, minus coincide part 45, 46. This one, not 45, the long line is a 45, then 46, 47, 48, 49, 50. It is 46 multiplied by 0.01 millimeter. It is 4 into 0.01 millimeter. It is 0.04 millimeter is the least count, not the least count, negative zero error. That's how we get the negative zero error. Are you good? Same as vernier caliper. In vernier caliper, total vernier scale parts minus coincide part. In micrometer screw gauge, total circular scale parts minus coincide part. Understand the difference? Same method. And this final point, this negative zero error coming due to the wearing off of jaws, anvil and spindle. Anvil and spindle ගෙවුනම තමයි මේකෙත් එන්නේ. The negative zero error coming due to this anvil and spindle, you know, when we use several years, it is wearing off, given. That's why this smooth layers between this anvil and spindle iron rod, it is removing smooth layers. Then that's why it is additionally rotate. Really think this concept, it is additionally rotate. That's why the negative zero error is coming. Then how we get the accurate value of, if we got measurement using this type instrument, how we get the accurate measurement? Adding or subtract? By adding or subtract? Negative zero error. Good. In positive zero error, it is subtract. In negative zero error, by adding. Very good. Adding. Okay. Final question for today. Okay, this instrument now get the error 0.6, because 45 is coincide. 0.6 millimeter negative zero error. This is the reading I got using this instrument. I got this type reading. Can you get the accurate reading? I need the instrument given reading. Quickly send me now. Time pass. Given reading, instrument given reading, and accurate reading. Quickly send me. Which one is the instrument given reading? This negative zero error of the instrument 0.06 millimeter. Please send your answers. This is the final part of the micrometer screw gauge. Okay, what's the reading? Yes, very good. The given reading is 2.33. 2.33 millimeter is the given reading. How we get the accurate? By adding -0 error. Then we can get the it is 2.39 is the accurate reading. The 2.39 is the accurate reading. Okay, that's all about micrometer screw gauge. Next week we start mass measuring instrument, and the lesson will be completed within next week, the measurement lesson. If anyone not complete measurement lesson, you can get the recording, and tute you will have within 3 days after your payments. Then you can complete the previous part we discussed in the measurement lesson. Any doubt from today part? Any doubt? Ravindu? Any doubt from today discussion? Vihanga? All clear? Okay, then practice and practice very well, and try for the do. I'll give you practice question after next week class. Then you can try a lot of questions. Tutorial discussion paper. Okay, that's all for today. Next week we can meet with the final part of the measurement lesson. Okay, goodbye.